Hello, mathematicians. I'm excited to start doing videos for you in this class. From now on, they will be accompanying any notes and then posted on that YouTube channel I shared the link for. So I will always post the homework assignment first, just to get you starting to read ahead and trying on your own. Remember, we talked about that productive struggling, and then I will kind of lecture through a little bit more to help guide you. So this is going to be the beginning of our finance chapter. This is on that online book under the title of finance. We're just going to be talking about interest in this section. So we're going to talk about simple and compound interest. So first we have to understand what interest is. So interest is going to be the amount of money paid to borrow money, or it's the amount of money paid to you for someone else to borrow money. So most of the time we hear interest on like a bank account. What's happening is we are making money on that bank account because the bank is borrowing the money from us. So when we're putting that money into that bank account, they are borrowing that money to be able to give other people loans, and then they're paying us interest since they're borrowing it from us. You might have also heard interest on like a credit card. In that case, we're being charged interest for borrowing money from that credit card account. So either way, it's amount of money paid to borrow money. And we're going to see that denoted with a capital I. But we have to talk about the rate, or the interest rate. So in our calculations, we'll see this denoted with a lowercase r. And this is the percent of the principal that's being charged. And I'm going to talk about principal in just a second. But think back to when we did taxes. We would say that the tax rate was the percent of some amount, or a percent of cost. Same thing here. The interest rate is going to be some percent of some amount that's being borrowed, or amount that we are letting the bank borrow. So the percent, or the principal, is the amount borrowed. So it's the starting amount of a loan, or the amount an account starts with. So this is going to be denoted with a capital P. And you're going to see in the book, or online in the ebook, that they use P with a subscript of a 0. We don't need to do that. It's okay if you just use a capital P, but just so you know, the notation is a little bit different. And then just like before, whenever we had a tax rate on the cost, and then we had to add that tax amount to know what we had to pay altogether, we have that same amount whenever we're talking about interest. So we're going to have an end amount, and that's going to be the principal, whatever amount we borrowed, plus the interest. And we're going to see that denoted with a capital A. So let's move on and do some calculations, start looking at some formulas. And also keep in mind, you can complete this with me, or if you're looking at a completed copy, I'm going to be writing down what's on my key. So it's up to you if it helps you to write it down with me, or if you just want to follow along. Either one's fine. All right, so let's annotate here. Let's see if it lets me write on this. You should be able to write. Simple interest can happen a couple different ways. So it could be a time where we are borrowing money, and then we're going to have to pay a one-time percentage fee to borrow that money. So in that case, it's going to be one-time simple interest, and we're going to see that denoted. Not really strong here. All right, we're going to see that denoted capital I, or interest, is equal to the principal times the rate. So just like we were doing with taxes before, we would say the tax amount is that tax rate times the cost. And then we would figure out at the end how much we had to owe altogether. So our final amount is going to be that principal plus whatever amount of interest is being charged. And then we can also write that formula in a couple different ways. So we could say, well, if we took the principal and added on the principal times the rate, notice we're doing the same thing. It just looks different in our formula. And then we can also write it to principal times 1 plus r. So whichever formula works best for you. I tend to want to do it as two separate ones, just so I can check my steps as I go along. So you'll see me do it using that formula and this one more often than using any of the other ones. So let's look at an example. This is going to be exercise 1. It's on page 222 if you are looking at your ebook. It says a friend lends you $200 for 1 week, which you agree to repay with 5% one-time interest. How much will you have to repay? So since it's asking for how much you'll have to repay, we're looking for the amount at the end, or A. We first have to calculate our interest amount. The interest is going to be the principal, or however much we borrowed. We borrowed the 200, and our interest rate is 5%. Just like we've seen so far, anytime we have a percent in our calculations, we want to denote that as a decimal. We're taking the principal times the rate, or 200 times 0.05. We end up having an interest amount of $10. This would be our final answer if it was asking how much do you have to pay in interest. But since it's asking how much we will have to repay, we need to take that $10 and add it to what we borrowed. So we're paying an extra $10. So A is principal plus interest, or 200 plus 10. That's how much we're actually going to have to pay our friend back. A friend who charges you interest is a questionable friend, but I understand. It's just for example purposes here. The other way we could have looked at it if we were comfortable with the other formulas is we could have said, well, the amount we're going to have to pay is the principal plus the principal times rate. And notice here, we're taking that 200 and then we're adding in 200 times that 5%. We end up having the same 200 plus 10, or the same A value or final amount of $210. So it's whichever formula you're most comfortable with using. Just keep in mind that if this was asking, or if the question was asking how much interest, this formula is not giving it to us. This formula is solving for A. So in that case, we're gonna want to use just this interest formula. Okay, I'm gonna clear this and move on. Okay, let's move on to more than one-time interest, more than one-time simple interest. So we're still talking about simple, and I'll explain what other types of interest we could have coming up shortly in this presentation. But before, we had a one-time interest charge. So it was you're borrowing the $200, and then in addition to that, you need to pay back 5%. Here it's saying, okay, well, maybe 4 times a year, or 12 times a year, or twice a year, or 1 time a year, we're going to charge that interest. So instead of before, where it was just like that flat 5% on what you borrowed amount, here it's going to say, okay, well, we're going to spread that out. So what we're doing is we're taking what is called an annual percentage rate, or APR, and this is the total interest rate for a year. And we have to divide that interest rate up in however many times, whether it's quarterly, monthly, semi-annually, etc., however many times that interest is being charged or being paid. So here, and I'm going to do more examples, so we'll see how that works in just a little bit. But here we're looking at a similar interest formula. So we have I is equal to P times R times T. And notice that the only different variable here is this T. We didn't have that in our last equation. That T is going to represent time. So it's saying, okay, how long are we taking this loan for? Or how long did we deposit money? How long was money borrowed, essentially? And the one thing to note here is that our rate, whether it's quarterly, monthly, semi-annually, annually, etc., it has to have the same unit as time. And I know that doesn't make a lot of sense just yet, but it will once we go to this next slide and the one after that. So we're going to do some examples with it. So we'll be able to see how to keep them the same and how that changes the answer. Here. Let's do a couple practice problems here. Notice the topic says more than one time or APR interest problem. So for example 1, I'm working out example 3. So since it's an example problem, this is one that is going to be worked out in your note packet or in your ebook. I just wanted to be sure to explain one of those problems through, so that way you weren't just reading it and figuring it out on your own. So example 3 on page 198 says treasury notes, or what are also called T-notes, are bonds issued by the federal government to cover its expenses. Suppose you would obtain a $1,000 T-note with a 4% annual rate, paid semi-regularly or semi-annually. Sorry, that's a little sloppy there. I'm going to write that one again. With the maturity, so what the maturity means is the final value So with the maturity in 4 years, how much interest will you earn? Whenever I do these types of problems, I always underline what it's looking for, and then I circle any important information. So I know that I have $1,000, I have a 4% annual rate, paid semi-regularly, for a time of 4 years. By circling that, it helps me figure out where I'm going to need to look whenever I'm going back with my formula to find certain pieces of information. So then I'm not looking at the whole thing again. I get to look at what I've already circled. So I'm looking for how much interest. So I is equal to PRT. Interest is equal to principal times rate times time. I know that our principal is $1,000. 2 blanks here. Notice that we have a 4% annual rate. So I know that that's 4% over the time of a year. So I'm going to write 4% over a year. And then we have our time in years. So one way that I could work this out is I could keep those units. I can have my rate 0.04 and my time of 4. In this case, they're both years. And I can multiply here to find an interest of $160. On these types of problems, always make sure that we're labeling the unit in our final answer. And I want to show this problem worked out one other way. So notice on this one we did years for the annual rate and years for our time. Let's say that we saw that the 4% rate was paid semi-regularly or twice a year. So otherwise every 4 months, every 6 months, sorry about that. So 4%, and then it says that it's paid every 6 months, and we're looking at years. I'm going to set this equation up. I recommend always writing out the equation to start off with. So that way, even if we make a mistake moving forward with what values we've used, at least I know that we have the right thought process starting off. So I know that we're thinking of the right equation. On these types of problems, it's always better to show more work than not enough, because then they can give partial credit where needed and kind of see where mistakes are happening if they are. So we have our formula. Interest is equal to principal times rate times time. Let's say that on this one, I wanted to work with 6-month time period. So let's say that I didn't notice that this was already set up as a year, and I'm looking at this semi-regularly. Well, my principal is the same. Now, if it's 4% a year, then I know every time it's paid, so it's going to be divided by 2. Every time it's paid, it's going to be half of that. So here my interest rate is 2% every 6 months. And then for time, since I need that to also be every 6 months, I need to ask myself, how many half a years do I have in 4 years? So I would have 8 6-month periods. If this way is more confusing, it's okay. Just stick with the first way I worked this out. So this is another one of those, whichever one makes more sense to you. So doing our calculations, we would end up with that same interest amount of $160. I'm going to clear this just to eliminate some of this work whenever I move on to this next example. And I'm going to do the same thing in this next example where I work it out 2 ways. Again, it's whichever one makes more sense. I think the first way on both of these is a little bit smoother than the second, but it's, again, whatever one is helpful for you. So on this next one, this is going to be exercise 2. So that would be from the problem set at the back of the chapter. Exercise 2 on page 222. Says, suppose you obtain a $3,000 T-note with a 3% annual rate paid quarterly with maturity in 5 years. How much interest will you earn? So again, I'm looking for interest. Notice on these, I know that I'm looking for the I is equal to P times R times T formula because I'm given a specific time value. So before, it was just a one-time loan, one-time payment. I didn't have to worry about the interest being more than one time or over a period of years. It just was, I'm going to borrow this. When I pay it back, I earn I had to pay 5% extra. On these, I have another time limit to consider. So suppose you obtain a $3,000 T-note. Okay, so that's essential with a 3% annual rate paid quarterly, maturity in 5 years. The first one I'm going to do is I'm going to do the same way that I'm going to work it out the same way that I did that first example last time. So I noticed that this one has the word annual in it. So this is 3% per year. My principal is $3,000. My rate, I'm going to go with my year here. My rate per year is 3%. And since that's years, I also need my time to be year. So I have it in 5 years here. And I can calculate, I'm taking 3,000 times 0.03 times 5, and the amount of interest that I will earn is $450. I'll give you a second to write that down if you are, and then I'm going to move on to another way to work this problem out. Okay, so let's work this out another way. Let's say that we're doing the 3% paid quarterly, and then we have 5 years. If it's paid quarterly, it's going to be paid 4 times a year. For every 3 months. Again, we're looking for interest. We have PRT. That principal, notice, is not changing here. So that's 3,000. But now if we're looking at it quarterly instead, I'm taking that 3% and I have to divide it into 4 payments. So it's going to be every 3 months. And then now my time has to match every 3 months as well. So if I'm looking at quarter years, there are going to be 20 in 5 years. So I'm taking 5 times 4 here to have 20 quarter year periods. It looks a little complex to simplify, but just go ahead and start with doing this one first in your calculator. We should have 0.0075. And then we're going to multiply that by 20 and then also by 3,000. Notice here after multiplying, we end up with that same interest amount of $450. Let's move on to one more example. So this is example 3. So try it now, number 1 on page 198. So the loan company charges $30 for interest for a 1-month loan of $500. I'm gonna go ahead and circle as I go through. So $30 for interest for a 1-month loan of $500. Find the annual interest rate that they're charging. Notice we have a disagreement already. We can identify that this one is 1 month, and it's wanting us to find the interest rate in a year. Let's go ahead and set up our formula. So we have interest is principal times rate times time. Here, we're being told the amount of interest that they're charging. Before, we had to always find the amount of interest. This time, they're telling us that I is equal to 30. And the principal, or the loan amount that we borrowed, is $500. Notice I'm looking for rate. I don't know it, so I'm going to just go ahead and put that R into that parenthesis. Over here for time, I find it's easiest, since we're looking for the annual interest rate, I'm going to try to express my time here in terms of years. If I'm looking at 1 month, 1 month is 1/12 of a year. To simplify, I want to multiply both sides by 12. So we would have 12 times 30, or 360, is equal to 500R. And then divide both sides by that 500 now. So I have 0.72 is equal to R. Just like before, if we were talking about a tax rate, for example, we could not leave it in decimal form. Same thing applies here. If we're looking for an annual interest rate, we have to make sure that that rate is expressed as a percentage. So this would be 72%. If you are ever, not that I'm a financial planner here, but if you're ever offered a loan with a 72% interest rate, do not take it. That is a lot of interest. A lot. Okay, let's move on to compound interest. Compound interest is a little different. So before, we had a set amount of interest per year, and then it was either paid at one time or it was paid multiple times throughout the year. With compound interest, what's happening here, and I hope to find a good illustration for you and to post on Schoolology, but what's happening here is every time that we are paid interest, we're adding that amount that we were paid and considering it to be our new principal. So now we're saying we're going to get 5% every single time on our new total. So we're going to put some money into an account, or we're going to borrow it one time, and then it's just going to build from there. So I want to try to find a really good visualization for you, just to give you a better idea of what's happening. So our formula here, and you will not have to memorize these formulas. On a test, I will give them to you, but I will not explain what every variable stands for. So you will have the formulas as long as you can identify, for example, what A is, what P is, what R is, you're going to be okay. And you'll be able to identify which formula you need. So here we're looking for A, or our final amount. A is equal to our principal times 1 plus R, so nothing new yet, but now we have a new variable K, and I'm going to explain it in just a second once I finish writing the rest of the formula. We have P times the quantity, 1 plus R over K, raised to the N times K power. Just a quick note, your book for A uses P sub N. They're saying what is the amount after a certain number of years. I find it's easier just to keep the same variables between formulas, just to kind of eliminate any confusion, less variables that we need to be able to identify. So the final amount here is just A, just like before. K is a new one. K is going to be the number of times the account compounds per year. So that's the same K here as up here. And then N is the number of years. If you're following along with your ebook out or your ebook up, it does explain it a little bit more on page 201. Notice the difference of what's happening here. So with a compound account, let me clear my screen. With a compound account, let's say that we put $100 in into an account. This is just going to be an example, and I am making this example up at the top of my head, so just bear with me. I don't have it written down in the key. But let's say that we deposited $100 into an account. It was a compound account, and we get 10% interest every 6 months, or in other words, semi-annually. What's happening here is we've only had to put in $100, but after our first 6 months, that first amount of interest is going to come into our account. So 10% of 100 is $10. So now in our account, we have $110. What that means now is going into the second 6 months, it's going to take 10% of, that $110. So it's going to be different than before, where we're only looking at that principal. Now the interest earned adds to our balance, and then we just keep accruing interest off of that. So now we're adding $11. So at the end of our first year, we're going to have $121. If it was just a simple interest account, $100 with the 10% simple interest, At the end of that first year, we would only have $110. So this compound interest account is always going to be the better deal as far as investing is concerned, because we're adding that interest into our balance and then taking the percentage of interest off of that. So it's just going to grow and grow and grow exponentially every time that it's compounded. Again, on page 201 in your ebook, it does show an account that is set up that way. You can see a simple account versus compound interest account. And again, I do want to try to find a link to help you visualize it a little bit more as well. Let's go ahead and jump on. We're going to do 2 examples here. Okay, this first one, it's exercise 7, so that's from the problem set. Exercise 7, page 222. It says you deposit $2,000 in an account earning 3% interest compounded monthly. So again, I'm going to circle the important information. $2,000, 3% interest compounded monthly. First part asks, how much will you have in the account in 20 years? So since I know it's a compound interest account, I'm going to go ahead and start just like I would any other column by writing down that formula. So A is equal to P times 1 plus R over K raised to the N times K power. And then I need to write whatever, or substitute whatever variables I know already. So I'm looking for A, it's asking how much will I have in 20 years. So our principal, or the amount that we deposited, is $2,000. Our rate here is 3%, so 0.03. K, so remember K is the number of times it's compounded per year. So if it's compounded monthly, we're going to say per year it's compounded 12 times. Our N here is the number of years, and then K, as we said, was 12. Whenever you're calculating this using a calculator, it's important to do it step by step. And I would recommend showing me as much work as possible as well. Just because a lot of times people try to work this all out into the calculator at one time, and just based on parentheses or maybe where they put an exponent, it ends up giving them an incorrect answer. So at least start off for me, please, and for yourself, by always writing out what equation you're using or what formula you're using, and then give me at least the first line so I know what values we put in for each variable. So what I'm going to do here is I'm going to keep this 2,000. I will first in my calculator simplify 0.03 divided by 12, and I should have 0.0025. And while I'm at it, I can also simplify this 12 times 20, so to the 240th power. I can go one step further here, 2,000, and then in parentheses, I'm going to add those together, so 1.0025 to the 240th power. Common mistake here is people want to write this into their calculator all at once. Try, if you can, to always think to do this portion first. So in your calculator, find 1.0025 raised to the 240th power. We should have 2,000, and then here in the parentheses now, or this part simplified, should be 1.820755. And now we can multiply. Keep in mind we're talking about money here, so it's going to be $3,641.51. That's going to be how much we have in the account after 20 years just from investing $2,000. It then asks, how much interest will you earn? So we know that this A, just like before we saw, is principal plus interest. So it's whatever amount we deposited plus whatever interest was earned. Deposited or borrowed. So we have A is equal to 3,641. And we have our principal as that 2,000. So I have 3,641 and 51 cents is equal to 2,000 plus I. To solve for I here, I'm subtracting 2,000 from both sides, leaving me with an interest amount of $1,641.51. So all I had to do was I had to deposit the $2,000, and then I didn't touch it. It just kept growing in the account by itself, and it was growing compoundedly, so exponentially. It would just continue to grow and grow and grow. After 20 years, I had almost the same amount that I invested in just interest. It's a pretty good idea as far as an investment is concerned. Let's move on to the last example in this video. This is exercise 9 on page 222. But how much would you need to deposit? How much would you need to deposit? So right away, I know that this is looking for our principal. How much would you need to deposit in an account now in order to have $6,000 in the account? So in order to have a final value of $6,000 in 8 years, that's our time. Assume the amount earns 6% interest, so that's our rate, compounded monthly. So that's telling us 12 times a year. I'm going to go ahead and write out the formula. So A is equal to principal times 1 plus R over K raised to the N times K power. I'm going to substitute in what we know here. So I know that I want a final amount of 6,000. I know I'm looking for how much I have to deposit. Our rate is 6%. K, it asks for the number of times it's compounded a year. So this is 12. We have 8 years, and then again, that value of 12. I cannot stress enough here how important it is just to step-by-step simplify. So you will have no concern with time on your homework or your test here. So take your time, please, and just step-by-step solve different portions of it. So I'm going to keep this 6,000. I'm going to keep this P there. I can go ahead and find 0.06 divided by 12. That gives me 0.005. And I can find 8 times 12, so that's going to give me 96. Okay, so let's simplify a little bit further. 6,000 is equal to P times 1.005 to the 96th power. Just like before, go ahead and simplify this part in your calculator. So I'm going to just move over here. 6,000 is equal to P times, so whenever I'm calculating 1.005 raised to the 96th power, I should have 1.614143. It's always better in your calculations to keep the numbers as far out that's within reason, right? I usually end up having 4 to 6 decimal places in my calculations, so that way I'm not rounding too much. If I round too much early on, my final answer will be pretty far off. So try to keep more decimal places in your calculations and then have your final answer be in the 2 decimal places since we're talking about money. I'm going to divide both sides now by that 1.614143. And I should have a principal now of about $3,717.14. And I'm saying that that's about, since now I'm rounding, that's about how much money I need to deposit now. So I would need to deposit about $3,700 to have $6,000 in the account in 8 years. Okay, I'm going to post this online and let me know if you have any questions as you watch this. I'm going to send an announcement that I've also posted it as well. And then try to attempt that homework. The due date is extended to Sunday night for that.